learning outcomes. At the end of this chapter, you should be able to Introduction. Table of content. 1.3 Continuity. Continuity at a point. Limits, and continuity, of trigonometric functions. Introduction. Explain the three conditions for a function to be continuous. Explain on limits of trigonometric functions, and the squeezing theorem. What is continuity? The limit of a function, as x approaches a can often be found simply by calculating the value of the function at a. Functions with this property are called continuous at a. Continuity at a point. Definition. A function f x continuous on an interval if it is continuous at every number in the interval. If f is defined only on one side of an endpoint of the interval, we understand continuous at the endpoint to mean continuous from the continuity at a point. Theorem. Definition of continuity. The function is said to be continuous if it is satisfy the three conditions below. Example of a discontinuity function: have a breaks or holes. Example of a continuous function: no breaks or holes. The following figures illustrate a discontinuity at x equals c. The following figures illustrate a discontinuity at x equals c. Example 1a. Figure 1 shows the graph of a function f, at which numbers is f discontinuous. Y. Solution 1. f(1) is not defined. Since condition number 1 not satisfy, therefore f x is discontinuous at x equals 1. Solution 2. f(3) is defined. Does not exist. Since condition number 2 not satisfy, therefore f x is discontinuous at x equals 3. Example 1b. Figure 1 shows the graph of a function f, at which numbers is f discontinuous. Y. Solution 3. What about x equals 5? f(5) is defined. Exist. Since condition number 3 not satisfy, therefore fx is discontinuous at x equals 5. Example 2. Given. Determine whether the function of f continuous at x equals 0. Solution. From the graph, the function is not continuous at x equals 0, then prove it. Example 2. Solution. Example 3. Given that is continuous at, find m and n. Example 3. Solution. Example 4. Given. Find the value of k if g, x, is continuous at x equals 3. Hence, determine whether the function is continuous at x equals 4. Example 4. Solution. Example 4. Solution. Continuity of trigonometric functions. Theorem. If C is any number in the natural domain of the stated trigonometric function, obtaining limits by squeezing. Theorem. Example. Obtaining limits by squeezing. Example.